Okay, in this video I'm going to show you how to use logic to make conclusions. We actually do that in two ways. We use both inductive reasoning and deductive reasoning, are basically two different processes by which our brain functions. Inductive reasoning is a process of reasoning that includes looking for patterns and making conjectures. In general, when we're using inductive reasoning, we are working from specific examples to a general conclusion. This is what we use when we complete patterns. You started this in kindergarten when you had a circle, a triangle, a square, a circle, triangle, square, a circle, triangle, and the teacher said, "What's next?" And you said a square, because you saw pattern, you saw it repeating, and you made a general conclusion that the square always has to follow the triangle because that's what you observed. Deductive reasoning is the complete opposite. You work from general rules, things you know to be true, and conclude that in specific examples that it will also be true because it is a general rule. So we use facts, definitions, properties, and proven truths to verify that something is true. We will get into that much more in geometry as we get into the proof process. Sort of a quick example would be we have the law of gravity, and if you hold something and let go of it, what's going to happen? And you're going to tell me it's going to fall to the ground, and I'm going to say absolutely, and I can verify it with my pen, which I just dropped. I know you can't see it, but it fell to the ground. Why? The general law of gravity tells me that no matter what you are holding, no matter what it is pulled to the earth by a gravitational force. Therefore, in the specific case, my pen will fall to the ground. Right now, we're going to practice inductive reasoning. We will get into deductive reasoning next week. So let's practice inductive reasoning. We are going to be looking for a pattern, making conclusions. And this fancy word conjectured really is just explaining what we observe when we're looking and finding a pattern. So the first one, I noticed that the numbers are going from 2 to 6 to 18 to 54. And they are changing signs. That's one way to think of it. We also can think that we could be multiplying or dividing by a negative. We'll make a positive change to a negative. So take a look, see if you can figure it out. Maybe pause the video. I'm observing that we are multiplying by 2 to get from 2 to 6, but if we make it a 3, if we make it a negative 3, 2 times negative 3 gives me negative 6, times another negative 3, negative times negative gives me a positive, and 6 times 3 is 18. And hopefully you're finding the next two numbers to be 162 and 486 is what I got when I calculated. So for my conjectural, all I'm going to do is write down in words what I have written with my times negative 3. It appears that we multiply by negative 3, okay, or we could say multiply by 3 and change the sign is another way of writing that. Try another pattern. This time I'm decreasing. Two ways to get smaller. We can divide, we can subtract. I'm not seeing any easy way to divide 10 by anything to get anywhere close to 9. So I'm going to say, let's go with subtracting and see what happens. I subtract 1 to get from 10 to 9. I subtract 3 to get from 9 to 6. I subtract 5 to get from 6 to 1. And although I'm not subtracting the same thing each time, and you be careful not to stop too early, just go ahead and figure it out and then observe, it does appear that there's a pattern in the way I am changing the difference between the two numbers. And what I'm observing is that it appears that we are subtracting 2 more each time, leading me to believe that I should subtract 7 and then subtract 9 for answers of negative 6 and negative 15. Another way of saying that is you could observe that we are subtracting odd numbers, and we would say increasing odd numbers. Or something like the next consecutive, meaning in a row, odd numbers, something like that. Okay, those are a couple patterns. Of course, every pattern is different. You got to just closely observe each one and do the best you can with those. What happens if we don't have a pattern? We don't have numbers we're working with, but we're asked to make a conjecture. The product of an even number and an odd number is, I'm supposed to decide if it's even or odd, and I have no idea. So what am I going to do? I'm going to give myself an example. Believe me, you can do this. Pick an even number. I'm picking 4. Pick an odd number. I'm picking 5. 4 times 5 because it says product. I'm going to go ahead and multiply them, and I'm getting 20. And now I can say that the product of an even number and an odd number is always even, right? Wrong. You can never decide off of one example. That could totally be a coincidence, and the next one could not work out. We don't know if it's always going to work out. Maybe we can't make a conjecture. So let's pick another even number. I'm picking 2. Pick another odd number. I'm picking 9. 2 times 9, I'm multiplying because it says product, and I get 18. Now I've got 2 cases where a product of an even number and an odd number came out to be even. Can I make the conjecture that it's always going to be even? I like to say 3. 3 is a magic number. Let's do one more example. So let's pick an even number. You can pick a different number than me. Pick an even number. Pick an odd number. Multiply them together. Hopefully you're getting an even number. It does appear that we're getting an even number. So at this point, we could keep doing more examples. Of course, we haven't tested every one, and that's why we say a conjecture is not a proven fact, but we're using pretty good observation here that we appear to always be getting the same thing. There's one more for you to try. Difference of an even number and odd number is, go ahead, give yourself a couple examples. Notice this time I'm subtracting when it says difference. 4 minus 5, I get a negative 1. Don't worry. We're just worried about if it's even or odd, so it's a negative. That's okay. Let's do a different one. This time I'm going to do 12 minus 9, and I'm getting a positive 3. And I'm going to do one more just for fun. 4 minus 3 gives me a positive 1, and let's see, I got an odd number, I got an odd number, I got an odd number. I'm going to say that it appears that the answer is always going to be odd. You can make conjectures about anything. I just did a couple of numerical examples to look at because it's easy to pick some numbers, but don't be afraid to draw a picture, give yourself a chart, somehow to give yourself some examples to generate good conjectures.